Hello, and welcome to the presentation where we will explore conceptual validation of vapor net primary production, also known with its acronym NPP, and the derived biomass of a crop. My name is Abbebe Chukala, and I am a senior lecturer and a researcher in irrigation engineering at IHE Delft Institute for Water Education. The crop net primary production NPP curve is a graphical representation of the temporal variation of net primary production over a growing season for a specific crop type. One can monitor the crop net primary production curve to validate whether it follows the trajectory of crop development stages. The curve of the net primary production rates, that is a cycle of dry matter production in gram carbon per meter square per day, typically shows an initial increase as the crop emerges and grows, followed by a peak or plateau during the reproductive stage, and then a decline as the crop matures and senesces. Vapor-derived biomass can be validated conceptually by checking the consistency of the vapor-derived biomass responses to water use. The consistency check of agronomic concept is important for rapid validation of vapor-derived production and water consumption variables, and in the absence of observed data. The following agronomic concepts hold true for a field well managed for its biotic stresses, that is, disease and pests free. Biomass has the strongest linear correlation to transpiration normalized for climate, followed by the correlation of biomass versus actual transpiration and biomass versus actual evapotranspiration. The linear correlation of biomass versus normalized evapotranspiration is stronger than biomass versus actual evapotranspiration without being normalized. Biomass water productivity normalized for climate indicates the photosynthesis pathway of the crop type. So if the biomass water productivity normalized for climate, it will indicate the crop type and its photosynthesis pathway, whether C3 or C4. The correlation of biomass with actual evapotranspiration increases if the dataset is subdivided for subhomogeneous clusters, such as by growing season and irrigation methods. Here is an example of conceptual validation by comparing the response of biomass to water consumption as it is shown on the screen. On the left is biomass versus transpiration, in the middle biomass versus actual evapotranspiration, on the right biomass versus normalized transpiration. Comparing the correlation coefficient of a linear relationship between variables in the x and y axis for regression line passing through the origin of the three graphs. Conceptually, we expect the correlation coefficient of biomass versus normalized transpiration is the highest, followed by the correlation coefficient of biomass versus transpiration and biomass versus evapotranspiration. However, contrary to our expectation, for this specific remotely sensed derived biomass and water consumption data, the correlation coefficient of biomass versus actual evapotranspiration is the highest. This implies that there is issue with the split of the water consumption into transpiration and evaporation. The other conceptual validation of using biomass response to water consumption is comparing the correlation coefficient of a linear regression line for biomass versus ETA and biomass versus normalized ETA. We expect that the correlation coefficient of a linear regression line passing through the origin for biomass versus normalized actual evapotranspiration is higher than the correlation coefficient for biomass versus actual evapotranspiration. As you can see from the table, the vapor-derived biomass versus ETA and biomass versus ETA normalized by reference evapotranspiration as a proxy for climate confirm the agronomic expectation. That is, the correlation coefficient is higher for biomass versus normalized actual evapotranspiration compared to the correlation for biomass versus actual evapotranspiration. One can consider the climate normalized biomass water productivity derived from remote sensing as a conceptual validation parameter. As this normalized biomass water productivity values indicate the photosynthesis pathways of a crop type, that is C3 or C4 crop. Researchers show that the climate normalized biomass water productivity of C4 crops such as maize and sorghum fall within the range of 30 to 35 gram per meter square. The range for C3 crops such as wheat, teff, rice are from 50 to 20 gram per meter square. The vapor-derived normalized biomass water productivity of sugarcane at Sinavana State in Mozambique fall within the expected range between 30 and 35 gram per meter square for the C4 crops, which sugarcane is. The correlation coefficient between biomass and actual evapotranspiration for a regression line passing through the origin is getting stronger as the dataset is subdivided by seasons and other management units such as the type of irrigation methods. The figure shows the correlation coefficient of a linear regression line passing through the origin for the whole dataset, which is 0.69. This value improves as the correlation coefficient is calculated for the dataset splitted by season and by irrigation methods. Thank you for your attention.